Find the quadratic function to model data. Let's take a look at this example. The number of higher order multiple births, triple or more, in the United States is shown in this table. Here X represents the number of years since 1996, and Y represents the number of higher order multiple births to the nearest 100. Use the data point 0 and 5900 and 4, 7300 and 8 and 7300. Find another quadratic model for the data on higher order multiple births. So these are the information we have. We need to write the equation. So in this case, we're going to use f of x equal to ax squared plus bx plus c, because we're using the quadratic equation as our model here. And we have some points from the table. If x is equal to 0, my equation here would be a0 squared plus b times 0 plus c is equal to, this is the point that is given to me, 0 would be 5900. When x equal to 4, this would be the number of the multiple births, which is 7300. If x is equal to 8, that's the number of the multiple births that we have from the chart. So we have 3 equations and 3 unknown. Our unknown here, in this case, we have to figure out the values of A, B, and C, because we want to write it in this model ultimately. So from the first equation, we can easily find the value of C, because when x equal to 0, the first 2 terms would be gone. So the value of C would be actually this number here. So now I know the value of C. I can plug it back into these 2 equations and make 2 equations and 2 unknown out of that. So let's take a look at the next 2 equations. Here we have, when x equal to 4, here would be 4 squared, which is equal to 16a, plus here would be 4b, plus C. I know what C is now. We can substitute 5900 for it. That would be my first equation. If I substitute C into the last equation, then I have another equation in terms of A and B only. So I have 2 equations now in terms of A and B. Because now I know what C is. I can use addition method or substitution method to solve the system of equation. I'm going to write this as 16x plus 4b. If I subtract 5900 from both of the equation, I can get it into this form. So now I can solve for A or B. We can eliminate B by multiplying the top row here by a number to make the coefficient of B opposite of each other. Go back, and for those of you who have a problem with solving a system of equation, please go back and take a look at the sessions I have as how to solve the equation using addition or elimination method. So in order to eliminate B, you need to multiply the top row here by -4. Multiply the top row here by -4. Then I would get -4 times 16 give me -32. -4 times 4 give me -8, and then I have to multiply this by 1400 to get -2800. So notice that I make the coefficient of B opposite of each other right now. So if I just simply add these 2 rows, the B cancels, you can solve for A. Once you find A, you can substitute that back into either of these 2 equations. So put it back into first equation and solve for B. Well, I find the value of A, B, and C. Now this would be my equation. That would be my model that I was looking for. F of x would be equal to -43.75a squared plus 525a plus 5900. Yeah, the only problem here is this is supposed to be multiplied by 2, not 4. Okay, let's fix that, because we're looking at the coefficient of B here is 4, Here we have the coefficient of B here is 8. You ask yourself, what times 8, what times 4 give you 8? So it's 2, not 4. So, let's correct that. So this is minus 2. If I multiply the top row by minus 2, then it's okay. Negative 2 times 16 is equal to negative 32. Negative 2 times 4 is negative 8. Negative 2 times 1400 is equal to minus 2800. So now I can solve for A and go back and solve for B. So we need to multiply the top row here by negative 2 to make the coefficient of B opposite of each other.